There. I'm Mr. Saem. Today we'll be discussing the Karnaugh map, one of the very important topic for A-level computer science 9618. So Karnaugh map basically was invented by Maurice Karnaugh. He invented it to do simplification for the Boolean expressions, Boolean functions. So Maurice Karnaugh, inventor, basically passed at 98 last year. So it's a special form of truth table which enables easier pattern recognition. Okay, it's a pictorial method of simplifying Boolean expressions, and it can be made up to 4 variables, or you can also make 6, but it's a lot better for 4 variables. So here you can see is we have is an OR. Okay, logic gate being used. We have input A and B and output F. We're going to plot it into Karnaugh map grid. As you can see over here is once we plot it, we have ones. So we'll make groups of ones later on. First, let's discuss some rules. First rule basically says is that we can only group where we have ones. Second rule says is that we can only group when we have vertical or horizontal. Diagonally, we cannot basically group them. We cannot group them diagonally, or horizontal or vertical. Then we have another rule that says that we can only group when we have 1, 2, 4, 8, but we cannot group when we have 3 or 5. Rule over here is, as you can see, is we have zeros. Then we can only group, okay, now we have a rule that we can group where we have is maximum. The group has to be as large as possible. As you can see, we have the group quite large over here. So when we have 2 separate ones, we will not group them separately. They have to be part of the larger group. Then obviously you can see again over here is that if we have 1, it should not be separated. It should be part of the group, right? So groups may overlap. That's perfectly fine. As you can see, groups can overlap. They don't have to be individually existing. So look at this following truth table. Okay, so we have made a Karnaugh map. You can see ones are appearing where A is 1. So the output over here we can see is independent of the output of value of B. So technically this is only A. Then what we have over here is we have, this is a very good example, where we have A inverse, B inverse. In the first situation you can see is when both are 0, 0, we have one group. It's independent of C, which is 0 and 1. Then we have A inverse and C. As you can see is A over here is 0 in that particular group, and C is your 1. Okay, so as you can see over here is A happens to be, in this particular case, 0, 0. That's why you can either you can have zeros or either you can have ones, but you can't have 0 and 1. So since I have 0, 0, I can obviously call it A inverse. Okay, and over here obviously AB and AB, you can see over here is both A and B are 1, 1. So next what we have over here is this situation in which we have A or B. This is actually just 1. We'll discuss it later on. This is A inverse and B inverse, where B is 0 and A is also 0. As you can see over here, A is 0 and B is also 0. So that's why it's A inverse and B inverse. Right, here we go. Then we have over here is where A is, where your A has 4 ones. So it's A, and you can see over here is B. In this situation, you can see is that B is 1, 1. In both cases, but your C is 1, 0. So 1, 0 will not be considered, obviously. It will not be considered in that particular case. So that's wrong and that's correct. So this is what we have. Look at the following Boolean expression. So we have plotted it for you in the Karnaugh map. Okay, so plot for you in the Karnaugh map. Can you simplify this? If you simplify this, what do you get? I can just pause for a while, or I can just wait for a while. Think of it. So what would be the simplified version of it? Okay, here we go. This is the output that we'll have. We'll have AB and CD. As you can see over here is AB is 1, 1 and CD is 1, 1. In that case, it will be AB plus CD. So this is what we have as far as your Karnaugh map is concerned. We discussed about the rules. We will be solving some past papers related to Karnaugh map and Boolean expressions in the next lecture to come. So wait till then. Okay, here.